Discuss the sandwich theorem. The students who don't know about sandwich theorem, now there's a best chance to them to know about sandwich theorem. Here you can see that in a figure the u represent a unit circle which is drawn on xy plane, and p is at any point we taken on the circle, okay, and we simply draw a perpendicular to x plane and we call it m, and we just extended the point P to point Q and draw a perpendicular from point Q to point A or x-axis. Now we have to discuss that the length, there are basically three areas. Number one, area of triangle AOP. AOP, this is a triangle. Basically there are three triangles: triangle AOP and triangle OAQ and triangle. Now I just again demonstrate you that we got three triangles in this figure. Number one is triangle OPA, triangle OAQ, and a sector. What do you mean by sector? Sector is a small portion of any circle, or you can say that the side of a circle. Okay, and in this figure we got one sector, that is OAP. In sandwich theorem we just compare three areas, okay, that which area is greater, which area is less, and then we can prove the sandwich theorem. Now from this figure you can usually assume that in this figure you can easily see that the triangle OAQ is greater than triangle OAP. Therefore the area of triangle OAQ is greater than area of triangle OAP. So I just draw the relationship on my board as I tell you that we got three triangles in this figure. One is triangle AOP and another is OAQ, and one more we got, that is a sector. As I told you previously, that sector is any side of a circle or a section, whatever you say that. In sandwich theorem we have to compare the areas of sector, triangle, and both triangles. As you can see that I have written that number one, area of triangle AOP. We have to find that area of triangle AOP, and second we have to find area of triangle AOQ, and third we have to find the area of sector, which I tell you that sector is any portion, that AOP. As you can see that I can write the relationship amongst the areas of three quantities. Number one, area of triangle AOP always less than the area of a sector, that is AOP, and both areas will be lesser than area of triangle AOQ. Or you can write this relationship as I can see that, or that area of triangle AOQ is greater than area of sector AOP greater than area of triangle AOQ. As you can see that I just write down the areas, how we can calculate. As you know that the area of anything can be found, area of circle can be found as half of base into height. Here base is fixed, whose value is actually 1. Base values is actually base equals to 1. Base is fixed, which is 1. Therefore you can see that area of triangle AOP equals to half of base into height, which is equals to half of, as it is declared that base equals to 1, so 1 into height of triangle AOP. Basically it is a circle, so in order to find the length of that particular triangle we have to draw perpendiculars. So that's why we consider the height of that perpendicular, which is sine theta or m of p, as I wrote down in above, mp equals to sine theta. Okay, therefore m of p equals to sine theta. Therefore area of triangle AOP becomes half of sine theta. Therefore next is area of triangle, the bigger triangle AOQ. The same scenario will be happen, that half of base into height, which is equals to half of base, which is declared as 1, and height will be a of q. A of q, as you know that I just wrote down above that a of q equals to tangent theta, therefore a of q equals to tangent theta. And last one is the sector area, area of sector AOP, which will be, as I can say that the sector basically is a small portion or a side of a circle. So it is related to a circle. Sector is related to a circle, therefore it involves radius and theta. So its formula will becomes half of r square into theta. Here we just, as I can say that we just take radius or a base equals to 1, therefore r equals to 1, therefore 1 square into theta equals to half of theta. Therefore we have just find three areas of AOP, area of triangle AOQ, and area of sector AOP. Now we just write down in the given relation as it is given above. As I write above, I just wrote down there the areas and compare their areas as above. I just compare the areas of both triangles and a sector, as I wrote down that half of sine theta is less than half of theta is less than half of tangent theta. What I just did that I just multiply the whole equations by 2. Okay, as I write down that multiply by 2, so we got sine theta is less than theta is less than sine theta by cos of theta. Now in next step I just divided sine theta throughout. So we just get 1 is less than theta by sine theta is less than 1 over cos theta. Now the next step is taking reciprocal, because our sandwich theorem is sine theta by theta. So we have to take the reciprocal, and you have to note down that when we are taking reciprocals of inequalities, the sign of inequalities also changes. And this is a key point of inequality, that when we take reciprocal, the sign of inequality also changes. Therefore 1 is greater than, as you can see that there is a lesser sign and there is a greater sign, therefore inequality sign will be changes. 1 is greater than sine theta by theta, and sine theta by theta is greater than cos of theta. Now I just did that, I just take limit theta approaches to 0 throughout. The limit theta approaches to 0, 1 greater than limit theta approaches to 0 sine theta by theta greater than limit theta approaches to 0 cos of theta. Okay. The limit of any real number will be a real number, therefore 1 is greater than limit theta approaches to 0 sine theta by theta, and limit of cos theta approaches to 0 will be 1. Therefore we got our result, limit theta approaches to 0 sine theta by theta equals to 1, which is our sandwich theorem.